Alright guys, let's talk about question 4 of AP Physics 1 2024 actual exam. There's a simple pendulum that consists of a small sphere and it makes an angle of theta with the vertical. It is released from rest at A and it comes to B, and the work done in this situation is WE. Then this entire system is taken to another planet with a mass same as that of Earth, but the radius is actually greater. The radius is greater than that of Earth. Again, the same scenario is repeated. That is released from A, comes to B, and in this case, the work done is Wx. So we have to justify that why Wx is less than We. All right, so first off, what is the acceleration due to gravity on the new planet? Let's call it Gx. The formula for G is Gm over r square, right? That is the formula for G. Now, on Earth, we have Ge is equal to Gme over Re square, and on the planet X, it is Gm of the planet, which is same as the mass of the Earth, so Me over Rx square. Now, it's given that the planet has a bigger radius, so since the value of Rx is greater than Re, and if the denominator is increased, obviously the numerator has to decrease, so Gx is less than Gy. So it makes sense that since the Gx is less than Gy, the work done is only due to the gravity, right? Because that is the only force which is acting. Now the work done due to gravity will be the force due to gravity multiplied with whatever distance it has traveled vertically. Let's say d, which is same in both the cases. So on Earth, it will be mgd. On planet X, it will be mg, let's call it ge, gx of d. And since we just proved that g of x is less than g of e, I don't know why I wrote y here, this should be e. So it makes sense that work done on x should be less than work done on e because the gravity has decreased. That's the reason why work is less. Now they are saying that there's a new pendulum which is designed with an elastic string, so the length of the string can increase or decrease depending upon the tension applied. On Earth, the time period of the oscillation is Te if it is released from theta, and on the new planet Y, where the radius now is same but the mass is larger than Earth, the time period is Y. So explain in a paragraph why Ty could be larger or smaller than Te. Okay. So first off, we know that the time period is given by 2 pi square root L over G. And we already have the formula of G, right? This is Gm over R square. Now, since the radius is same, but the mass of the new planet is more, since mass of My is greater than mass of M Earth, this means that the G of planet Y is greater than G of Earth, right? Now, if the gravity of the of the new planet is more, it will make sense that when a string uh, is hung from this mass, due to more gravity, the tension will also be more, right? And because of this, it will stretch because the gravity is more, so this thread will stretch because this is elastic in nature. So we can also agree that length on of the string on planet Y is greater than uh, length on Earth because the gravity because of more pulling force. So this is all our as of now kind of a math involved over here. Now the perhaps the paragraph will look like this. Let me just decrease the font size a little bit. Okay, right. We're gonna say that on the new planet Y, since G is more, since the mass of Y is greater than mass of Earth, uh, also L is more as a pulling force on Y is more than the pulling force on Earth. Since the time period is dependent on both L and G, it is quite likely that, uh, in fact, L and G, since the time period is dependent on both L and G, and both of them increases, it is quite likely that L over G is either greater than 1 or less than 1. So both situations are possible. So time period of Y could be greater than time period of Earth, or time period of Y could be less than the time period of Earth. I think this should justify this, right? Yeah, I think this is our paragraph. This is how we will explain the situation. I hope this makes sense. Any questions, please post it on the comment section. I'll see you in the next video. Bye-bye.